So let's just kind of run through here and talk about the polar coordinate system. So again, I asked you guys to read this on your own, and you hopefully did that. Now we'll run through a couple of examples and kind of talk about this a little bit in detail, but I'm just going to kind of do it in just with either super specific examples or kind of in generality. I'm not going to do like the form list of formal lectures because hopefully we kind of read about this and talked about it a little bit on our own, but we'll talk about it enough here to kind of fill in any gaps that might have kind of popped up, okay? So the polar coordinate system, we plot our points as r comma thetas. So r is our radius and theta is our standard form angle. So each one of these circles is a different radius. So this first is r equals 1. The next circle is like r equals 2, and so on and so forth. Oops, I changed color. I promise I did. Yeah. I don't remember. Check the review. Whatever's given with the review packet is what you get on the test. I don't remember though, but that's why I put the review packet or set the review up like that, so I don't have to remember. You know what I mean, Keith? Okay. So that's what we mean by r. So like a theta, let's say that theta was 30 degrees. Well, a standard form angle, its initial side is the positive x-axis. 30 degrees would be here. Okay with that? So if we wanted to plot the point, say, 3, 120, so I'm going to be using a circle whose radius is 3, which is that one. And that 120 degrees, well, my initial side is here. So 30, 60, 90, 120 is there. So there's like 120 degrees. So my point here, 3, 120. Okay with that? Okay. So the natural question then would be to where is the point, or what happens if I have like a negative value for r, right? Because that doesn't exactly make a lot of sense. So perhaps let's think about if we had like -2, pi over 3. So what the heck would I mean if I have a radius of -2? In this case, what I'm going to be doing is I'm going to still be using the circle with radius 2. And I'm still going to find my angle pi over 3. Note that pi over 3 is 60 degrees. Remember, how do we do that conversion? So we multiply by 180 over pi, right? Converts radians to degrees. So 60 degrees would be here, right? But since it's negative, what we're actually going to be using is this end of it. So we're basically kind of using the negative vector equivalent. Note that this is basically the same thing as 2 comma and then 240 degrees, right? So we can always go ahead and name that with a positive radius as well, with the, what's that angle called? I don't know what you'd call that. But you guys get what I mean, right? Basically, I just reflected, basically treated it like the negative vector, right? So I took that vector, that 60-degree vector, and just negative 60-degree vector, and did that. Everybody feel okay about just plotting these points? Okay. If it was a negative angle, we do the negative angle the same way we did before and just go rotate clockwise instead of counterclockwise. But that's no big deal, right? Feel so far so good? Okay. So one of the things that we'll be interested in is being able to determine like points that coincide. For example, like we saw here, 2 pi over 3, or I'm sorry, negative 2 and pi over 3, and positive 2 and 240, or what is that? That's 4 pi over 3, are coinciding points, like we're describing the exact same position. Are those the only pair of points that coincide at that location? Let's ask that first before we write out a definition. Think about that for a moment. Are those the only pair of points that would coincide at that specific location? Not sure? What if I did negative 2 and 7 pi over 3? Where would that be at? What's the 7 pi over 3 is the same thing as pi over 3 plus 2 pi, right? Is that going to be describing the same angle? Yes, because they are coterminal, right? That was the name we gave those kinds of angles. So, well, now there's 3 points that are coinciding. How many points do you think we can find that are coinciding like that? A lot. Infinitely many. Why? Because there's infinitely many coterminal angles, right? Everybody's okay with that? Okay, so I know that a point r theta coincides to the point negative r and then theta plus pi. Right? This was basically what we saw when we had negative pi over 3 coinciding to positive 2 and then 4 pi over 3. Everybody's okay with that? That's kind of our general rule. And if we generalize further from there, anything coterminal would also coincide. So far, so good. And then obviously we could make the same argument if we wanted to you know, put them in degrees or whatever. I guess we should say where k is just some integer. We cool there? So if I want then all the points coinciding with, say, square root 2 and then negative 234, well, I'm going to have square root of 2, comma, negative 234 plus 360k. And then I'm going to have negative square root of 2, comma, negative 234 plus 180 degrees plus 360k. And if I add the negative 230 and the 180, I get what? Negative 54? Is that right? Does that feel okay to you guys? No big deal, right? Just kind of using the formula. Okay, so what if we want to convert between our rectangular coordinates and polar coordinates? That would be something that potentially could be helpful for us. So if we recall all the way back to like first semester, if I have some circle where this is my radius and this is my angle, I can make like a right triangle out of this situation, where the x-coordinate there is going to be r times cosine theta, and the y-coordinate is going to be r times sine theta. So using this, my x-coordinate is just going to be negative 3 cosine of 148, and my y-coordinate is going to be negative 8. This is exactly what we did when we resolved a vector into like component form, right? You guys remember doing that a chapter or two ago? So when I type that into my calculator, I get about negative 254. And when I type this into my calculator, I get about negative 159. Now what's a little bit trickier here is to go from rectangular coordinates back to polar, but still not so bad. So let's say we have the rectangular coordinate negative 3, 2. So again, if we're thinking back to our circle situation, what we have is x and y, and that's r, and this is theta. Well, obviously, r squared is going to be x squared plus y squared, right? Just by the Pythagorean theorem. Ava, do you have a question?
I had a question about the phone forms. I got positive 2.54.
Oh, yeah, you should have. My mistake.
Thank you.
Yep, no problem. Thanks for double checking. Everybody's good why that is the case there? So I do get 13. So r is the square root of 13. Everybody's feel okay there? Furthermore, I know that tan theta is equal to opposite over hypotenuse. So I can say here that theta then is tan inverse of negative 3 over 2. And when I type that into my calculator, I get, oh yeah, right, let's think about it this way. So we have, yeah, Ava?
Sorry, is 2 the y or is negative 3 the y? Put negative 3 above 2.
Yeah, so yeah, that's good. Yes, I got that goofed up. That's fine. We'll get it straightened out, but I made a mistake before that I should have done. So remember when we're finding tangent inverse, we have to be a little bit careful about this, right? So we have to think about kind of where we're at. So negative 3, 2 is over here. So this is the angle that we're searching for. What we're going to find is taking tan inverse of the absolute value of y over x. That's going to give us this angle phi. And then our theta then is going to be 180 minus. So when I do tan inverse of 2 over negative 3, that comes out to be about 33.69. And when I do the 180 minus that, I get about 146.31. So I'd say my answer is square root 13, comma 146.31. Is that the only way we could express that answer? No, for example, we could have also done like negative square root 13, comma 6.31, and then like coterminal things to those two, right? I don't know why you'd want to do it that way, but you could. It wouldn't be wrong. But that's kind of the gist of the polar coordinates. So just talking about graphing, how to graph them, how to convert back and forth between rectangular and polar. Are there things from the homework that you guys want to talk about before we move on with new things? Be happy to take a few minutes here and answer some questions that you guys might have worked on from the homework if you have some. Therese? You said 37? 47. Okay. So you're standing exactly 15 feet away from the front of an 18-inch diameter circular target on the ground. Okay, so here's me. There. And there is my circular target, 1 feet. 18 inches is the same as a 1.5 feet, right? I'm just going to convert it now into, so it's everything's in 1 unit. At some point, I'm going to have to pick whether I want to work in feet or inches. I'm choosing feet. You throw a lawn dart in the direction of the circle. Yeah, what's the lawn dart look like? It probably has like a little thing on one end and like a pointy thing on the other. You release it from 5 feet above the ground. With an initial velocity of 30 feet per second at an angle of 70 degrees above the horizontal. Will your dart hit the target? Okay, so what I'm going to do is I'm going to write my position function. And then I'm going to solve y of t equal to 0. This is going to tell me how long and then I'm going to take that solution for t and plug it into x of t. This will tell me how far horizontally the dart goes. And basically I'm looking at whether this is, if that value x of t needs to be 15 and 16.5. Does that make sense so far, kind of what I've outlined, Therese? Yeah, you can certainly go wherever you'd like. So I'm just kind of outlined what my plan is going to be, because I think on these story problems, that's as much of the issue as the actual mechanics of like doing the solving and figuring things. You know, you have to think about a little bit what it is that we need to be doing, and understanding like what we're doing is often harder than the actual doing. Okay, so if I take my projectile motion formula, my position is the initial velocity cosine theta times t, and my horizontal or vertical position is this. So if I plug all this gobbledygook in now, I have, x of t equals 30 cosine 70 t, and y of t is going to be negative 16 t squared plus 30 sine 70 t plus 5. And so I'm going to take 16 t squared plus 30 sine 70 t plus 5 equal to 0, and solve that for t. Now clearly that's a quadratic, and it's definitely not going to be factorable because of the stupid sign floating around in there, so I'm going to go straight to the